Remember maths class at school? And there were always those kids who used to say, when are we going to use this in the real world? Maybe you were that kid who used to say that. Well, if you stick around during this video, you'll see a situation where that kind of maths is going to be used to help us fabricate panels for a car. Now everyone, Happy New Year and all that. Hope you had a good one. We're going to be doing some calculations today, as you can see by the whiteboard that's beside me. We're going to be using chords and bisectors and whatnot, and trigonometry to work out how our radius is on our rear arches, because we're putting 3-inch bigger tyres on. We need to make the arches a bit bigger. You can do it just by sort of knocking a wheel arch up and going, well, that don't look quite right, and stretching it out and all that sort of stuff. But number one, it takes longer. Number two, you tend to waste a lot of material. And number three, a lot of time it looks pretty lousy at the end of it. So we're going to do it the posh way and do some calculations. So the first thing we need to do is work out what our radius of our wheel arches are, our current tubs. Which if it was like a perfect arch, would be really easy. So if it was like say this was I don't know, a metre wide diameter, and that measurement there to that measurement there was 500 millimeters, then it'd be easy to work this out. But because we're working on a car, and I've never come across a car yet that has perfect wheel arch tubs, it's not that easy, because our problem is, so this is the diameter or the radius of your wheel arch. Our biggest problem is, at the moment, that's our rear floor inside the car, which means we can't actually work out, just taking one measurement, what our radius of our wheel arch tubs are. So we've got to do some calculations, which is where chords and bisectors come in. That's your chord. And that's your bisector. One of the important things to remember about bisectors is that bi, so it's two. And it's two equal portions, which means that this measurement here is 90 degrees, and that'll come in later. So we've got to take these two measurements, which is what we're about to do now, and then we'll be able to carry on and work it out. But basically, we'll call this A, and this B, and the formula that we've got to use is basically A squared plus B squared divided by 2A, and that will give us our radius of our wheel arch, essentially. So first things first, we've got to work out what measurements we already know, what we have. So what we're going to find is we're going to find out this width and also the height from the floor, and this is why we have to use chords and bisectors, because if this was like a perfect arch where the radius from the floor to the outside of the arch was half of this diameter, then that would be an ideal world, but they never are. So we're going to have to use chords and bisectors to work out what this radius actually is. So we're going to, first things first, like I say, we're going to just find out what our measurements are. And because this arch is a little bit domed, and we've got this spring seat here in the way. We can't just measure along here, so what we're going to have to do is I've made sure this is square with the back of the shell, this framing square, and then I just make sure it's parallel with this this front cross member here. That's 145. And then we just measure from our framing square to this bit of bar here, and it is 745 millimeters. So that is 745 millimeters there. And then we need to find out what this height is. Again, because it's sloping down, we can't just measure off the height, so we're going to use a angle finder. Make sure it's nice and clean. We're just going to check what angle our shell is on. Which is 1 degree. Kind of what you need, like 5 hands. And then we set our angle finder to the same angle that the shell's at, and we measure here, and that is 255. So 745 and 255, there are our measurements. Okay, so we've got A, which is 255. We haven't got B. We've got a measurement of 745, which is this distance here. We want a radius, so we're going to take 745. Find a calculator. We're going to divide that by 2, which gives us 372.5. So what we do, we take 255 squared and 372.5 squared. We divide that by 2 times 255, which gives us 255 times 255 equals 65,025 plus 372.5 times 372.5 equals 138,756.25, and then we divide that by 2 times 255, 510. So 65,025 plus 138,756.25 equals 203,781.25 divided by 510. Equals 399, and we'll just put 0.5. We don't want 0.6, we won't work with that tire tolerance. So 399.5, that's our radius of our arch. Okay, so here to here is 399.5. Hoping you can see that. If not, you can hear me. Okay, So our radius, so we started out with 745. So we'll take our radius, which is 399.5, and multiply it by 2. We have a new radius of 799 millimeters. That's what our radius, our diameter, sorry, is of our circle. Okay, get rid of all this now. Take a note of it all. Our diameter is 799 millimeters. Like that. So 799 millimeters. That's with 27-inch tyres, and we are putting 33s on, which is 6 inches bigger, which equates to, we take, so we're putting 6 inch bigger tyres on. So if we convert that to metric millimeters, 6 times 2.54, 6 times 2.54 equals 15.24. Because we're working in millimeters, just move that decimal place across. 152.4. We'll get rid of that decimal place. 152 is plenty for us. So, anybody who's ever put bigger tyres on a Niva, so the 27 is factory. If you go up to 29-inch tyre, you've got to cut the arches anyway, but you only got to cut the outer arches. And anybody who's ever done it will know that the back arch, even if you cut the arch as far back as it'll go, the inner arch still limits how far you can cut it. So it will rub, and it actually cuts your outside cleats on your tyre, where your arch folds in. It actually cuts the outside cleats. So I'm actually just gonna add 25 millimeters onto that, just to make it so that it doesn't catch. If we only add 3 inch onto our radius, or 75 millimeters roughly, onto our radius, it'll still rub when we put our bigger tyres on. So I'm actually going to basically add 3.5 inches. So we're going to make it 177 millimeters bigger, our radius. Have I got that right? No, I haven't. Yes, I have, yeah. Our diameter is going to be 177 millimeters bigger. So 799 plus 177. 976, that's our new diameter. Divide that by 2. 488. And that's our new radius. So when we roll our sheet metal and whatnot, we need to be rolling it to a radius of 488. Witchcraft. Okay, so this is our new arch now. This is going to be our new arch, and we're going to go from our centre to here. We now know that these measurements for our radiuses are 488. Alright, so we've got our new radius, which is 488, or a diameter of 976. So what we're going to do now is you could actually just roll yourself a circle out of sheet steel with a diameter of 976, and then just cut it from there. And to be honest, your waste wouldn't be that much, your material waste, but it's we started to show you how if you wanted to, you could actually calculate what length you need to cut your material to. Normally, if you were going to be like really precise with your fabricating, you'd work to what's called the neutral line, which is if you're working with like 1 mil steel, most carbon steel, I think the neutral line is 0.42, I think, off the top of my head, into to the middle of your thickness of your plate. So on 1 mil mild steel, it'd be 0.42 millimeters. So you'd add that or deduct it from all of your measurements for when you roll it. So your outside of your carbon steel stretches and your inside shrinks, and your neutral line is the measurement that stays exactly the same throughout folding, and it's called a K value basically. You can research more on it if you want to research K values. So we're going to calculate. So this is our, from here to here, that's our arch on the inside of the shell. We're actually going to add a bit onto it as well for the back end, and so if you look at it from the inside, the arches sink below the footwell. They sink below the footwell. So we're going to add a little bit onto it, but not today. We're just going to do a rough calculation. So we're going to use a bit of trigonometry really to calculate this, because this isn't 90. If it was 90, you'd literally just be able to take your diameter and divide it by 4. And if it was 180, then you'd just take your diameter and divide it by 2. Well, you take the diameter, multiply it by pi, and then divide it by 2. But we can't do that because we haven't got such a fortunate angle. We have got one angle, which is what I said earlier on when I said take a note that this is 90 degrees. That means this here is 90 degrees as well. Which means that we can use trigonometry, calculate calculate this angle here. Essentially, this is the angle that we want, and then that'll give us our overall angle if we multiply that by 2. So when we use trigonometry, we have the hypotenuse, the adjacent, and the opposite, and these are our 3 sides. The hypotenuse, everybody always says it's the one opposite the 90 degrees, or the 90 degree angle. And I don't particularly like that phrase, and I'll explain why in a minute. I always just go by hypotenuse is the longest side. So this is our hypotenuse. This is the lesson that everybody in school goes, when are you going to use this in real life? Well, here we are. And then your adjacent is the side that joins the 2 angles together. So it takes your 90 degree angle that you've already got, and this angle here, this is the one that we're trying to work out. So this is our adjacent. I can find somewhere to write it. Adjacent, joins the 2 angles together that you're wanting. And then this is our opposite, and this is why I don't like remembering that the hypotenuse is opposite the 90-degree angle, because our opposite is opposite the angle we're trying to find, and it can get quite confusing when we start throwing around, you know, hypotenuse is opposite the 90-degree angle when you've got a line called opposite. So there we go, 3 sides. I've got somebody here now. Right, sorry about that. It was New Year's Eve and we had family arrive, so I had to cancel the video at that point, and it's now a few days later and I got a bit of a cold, so joy of joys. Anyway, where were we? We were at adjacents, opposites and hypotenuses. So what are we going to do with those? I've come into my room now and I'm at my desk, so I've got this all drawn out on some paper. But what we do is we take this word here, SOHCAHTOA, and that gives us the formula that we're going to use. So obviously if we had the way we're going to work out this angle is we need to know at least 2 sides. So if we wanted to work out this angle, we'd have to know the adjacent and the hypotenuse. But if we want to know this angle here, we'd have to know the opposite and the hypotenuse. So we're going to be working out this one, so it's adjacent and hypotenuse. And that's telling us that we then need to use cos to calculate this angle here, because we've got our adjacent, which is the A, and our hypotenuse, which is the H. Now if we wanted this angle here and we had the opposite and hypotenuse, then that would be the sign that we'd need to use. So we've got our calculator here. I'm hoping this is going to come out all right. It's coming out not too bad actually. And what we do is we have if we were working out a missing length, for example this missing length here, then we'd just use standard cos. But because we're working out an angle, we have to use the inverse, so it's cos negative, cosine negative, and then we just tap on that and we put 2, 3, 3, because our adjacent comes first, divided by 4, 8, 8, close our brackets, and that equals 61.48. So we're going to go with just 61.5. 61.5 degrees. And because we're going to be working out this whole arch length here, this blue line here, we'll multiply that by 2. 61.5 times 2 equals 123. 123 degrees, just like that. So the next thing we need to do is we need to work out what to do with this angle. So what we're going to do is we're just going to get, because a circle is 360 degrees, we take 360, divide it by 123, and that equals 2.92. Remember that number. So we know that that's 360, but what we need to do now is we need to work out the whole length or the whole circumference of this circle. So we know that our diameter is 976. So we take 976 and we multiply that by 3.142, or otherwise pi, which gives us 3066. And then to work out this length here, we literally take 3066 and we divide it by 2.92, which gives us 1002.
1050. So if I was just making the arch so that it went to the floor in the Lada, and that was all I was bothered about, then I'd cut a sheet of 1mm at 1050 long, and I'd roll it to a radius of 488, and then that roughly would be that shape. But what I'm going to do, say this is the floor in the Lada, the arch actually extends slightly past the floor to the underside of the vehicle, and on the back not so much. So this is the back of the car, and it goes down to about there. But what I'll do is I'll literally just get a tape measure and just measure that distance there and that distance there, and then just add that to the 1050 before I cut the sheet, and then I'll roll it to a radius of 488mm. So it's really that simple. Like I say, you can mess around with card and mock it up with card and stuff like that. But I think the way I'm going to do it is I'm actually going to make these arches, including this panel here that's going to fill in the arch. I'm going to make that before I cut the original arches out of the car, just to stop it from getting any flex or anything like that while it's sat in the field. So if I make these arches, I can then put them straight in after I've cut the old ones out, which will make it keep that rigidity in the chassis. I'm also gonna so on the inside of the arch, so the side that the tyre sits in, there's a brace from the factory. So because I'm moving this inner arch inboard into the vehicle, I'm gonna have to put a new brace because the chassis is on the inside, on the other side of the wheel arch. So I'm gonna have to make a brace that sits on top of the chassis and gussets up to somewhere near the top of the arch here. So I might do some pattern development with that, and I like pattern development. And then I'm gonna have to put some more braces on the inside of the car as well. But yeah, so basically what we need to do is we need to cut a sheet of 1mm at 1050 long plus whatever these measurements are here, and then roll it to a radius of 488, and then we can make this panel here to fill it in, which is simply just, again, cutting a sheet out with a radius of 488, and then we'll put some fancy pressings in it and whatnot, weld it all together, and hopefully it'll look factory to those that don't know. That's what I'm hoping for anyway. Alright, thanks for watching. Again, Happy New Year. Hope you all had a good one. And hopefully this video wasn't exactly too boring. It's a lot of theory, but a lot of people don't realise just how much time theory can save you when you're on these kind of jobs. So thanks for watching again. Cheers for now. Bye bye.